I know what you're thinking. Wow, radiometry. I'll never get that 5 minutes of my life back. You won't, and I can top it because we're going to now do photometry. Photometry is the measure of EM radiation You're never going to get this 30 seconds back either. As perceived by the eye. Unfortunately, in the world of instruments and everyday things, they don't use radiometry, they use photometry. So I'll tell you why in a minute. I want you to at least have this information. First, let's imagine we have 3 panels up on the wall. I guess I could have actually projected 3 panels on the wall, but I'm not going to. So let's imagine 3 projections on the wall. One over here is blue, one over here is red, Lord, red, and one in the middle is yellow-green, the middle of the spectrum. All right, and they all have the same, what would it be? Exitance, same radiant exitance, to use your new words. They are all emitting the exact same amount of watts per meter squared. Just these are doing it blue, these are doing it yellow, and these are doing it red. Okay? If you look at those and you have fairly normal vision, then this one would look brighter, and these two would look dimmer. And the reason is, spectrally, our eye is not flat as a detector. It detects best in the middle of the spectrum, the yellow and the green, and it gets poorer and poorer out at the ends of the spectrum. So we can plot the luminous efficiency of the eye. The eye, it's called V for some reason, and versus lambda, and we look from about 400 to about 700, and you know, it just kind of, it's just a peak. Right? That's probably a little dull. It's probably a little sharper than that, and yes, for some of your weird friends, it goes outside 400 to 700, I know. But that's the idea. Is you're most sensitive here in the middle, this one would actually look brighter, even though an instrument would tell you they're all emitting the same watts per meter squared. So we have a whole new set of these crazy units, and I won't spend as much time on them. The first one is luminous flux, and I'm going to do them in the same order. So you're seeing how they correspond. 5V in lumens. They also have their own units, LM. So that's the equivalent of power. Right? Lumens is like watts. Then there is the luminous exitance. And that was MV. And that is in lumens per meter squared. Okay. Next is the illuminance. And this is like the radiant exitance. Right? Next is the illuminance, which is EV because it's like the irradiance. And it is also in lumens per meter squared. Or lux. A lumen per meter squared is called a lux. Could you do your luminous exitance in lux if you want to look like a fool? But really, lux is for the illuminance. Okay? Then there is the luminous intensity. All right, that would be IV, and it's in lumens per steradian, LM per steradian, or candela. And you can imagine where the unit candela comes from, a CD. Oh, no, it comes from a candle, but it's abbreviated CD. Lux is abbreviated sometimes LX, but I'm not sure what the point of that is because, you know, it's only a 33% savings. And then there is the luminance. Don't mix up the illuminance with the luminance, and that is LV, and that is in lumens per meter squared per I'm sorry, it's in candela per meter squared, right? CD per meter squared, which is the equivalent of lumens per meter squared per steradian. So candela per meter squared, or it has its own name, nit. It's in nits, okay? The reason I tell you this is sometimes instruments will give you their sensitivity in these strange units, right? The sensitivity of a camera, it might say, well, it can detect about 47 lux, right? So now you know what lux means. It's lumens per meter squared. What's a lumen though? Right? So what we got to do is give you the conversion. How do you get from radiometric units to photometric units? And here it is. This is the whole point. The photometric unit equals V, so it actually depends on where you are on this curve. The unit means different things for different wavelengths, right? So they might specify the sensitivity at a certain wavelength. Or if they don't say anything, they probably mean the center, where it's 1. It's V times the number 685 times the radiometric unit. So in raw numbers, if you're doing radiometrics in MKS, photometric numbers are bigger, right? 685 times bigger. This thing varies between 0 and 1. But the fundamental difference is they do depend on wavelength. Radiometric units don't depend on wavelength because they don't care about the eye. So there it is, radiometry, photometry. Now this should cover any weird unit that you ever see.